Okay, welcome back to MacNab Chemistry. Today we're going to have a look at endothermic and exothermic reactions. Okay, first of all, these chemical reactions are all about taking in or giving out heat energy. Okay, and in a chemical reaction you can monitor this using a thermometer. Okay, so first of all let's have a look at exothermic reactions. So exothermic reactions. Okay, so an exothermic chemical reaction is one which gives out heat energy. Okay, as the reaction takes place, the reactants lose energy as their stored chemical energy is given out to the atmosphere as heat. Okay, so in an exothermic reaction, basically heat energy is given out, and you can detect this in the atmosphere around the reaction as the atmosphere around the reaction gets hotter. Okay, this measure of heat content of a system then is called enthalpy. Okay, which has the symbol delta H. So when we're talking about heat energy changes in chemical reactions, we're talking really about the enthalpy change. Okay, this triangle here is a delta, which means change in, and the H is heat energy. Okay, so delta H is the enthalpy change, where delta means change. So delta H is your heat energy change. Okay, now it's really important to remember that delta H for exothermic reactions is always negative. Okay, so we could write this like this, so delta H equals negative. Okay, right, so next job then, let's have a look at the energy level diagram for an exothermic reaction. Here we have it. Let's just get that straight up there. Okay, right, so on my y-axis here, okay, I've got energy change, and on my x-axis I've got the progress of the reaction, so the time for the reaction. Okay, this is the energy that my reactants have, and then when they react, this is the energy that the products have. So in an exothermic reaction, the reactants have more energy than the products. Well, that makes complete sense if you think about it, because in an exothermic reaction, heat energy is given out. Okay, so some energy has gone somewhere. So if the reactants had this amount of energy, they give out heat energy, energy is released to the atmosphere, and the products that are left behind have this amount of energy here. Okay, right, so we need to understand this graph. Okay, so this little area here, this little hump effectively in the curve, that's called the activation energy. Okay, and the energy released to the atmosphere in the reaction goes from the reactant line to the product line. Okay, so let's have a little look at this. So remember, because energy is released by an exothermic reaction, if a thermometer is near the reaction, it will detect the increase in heat energy of its surroundings, and its recorded temperature will go up. That's really important for exams. Okay, if you have a thermometer reading in an exam and it goes up, that tells you that the reaction is exothermic. Okay, examples of exothermic reactions then would include combustion reactions and neutralization reactions. So combustion reactions and neutralization reactions are good examples of exothermic reactions. Okay. Next then, let's have a look at endothermic reactions. So these are kind of the opposite really to exothermic reactions. Okay, so endothermic reactions. An endothermic chemical reaction is one which takes in heat energy. As the reaction takes place, the reactants gain energy as they change into products, so the energy in the system gets greater. Okay, so remember, how do we measure the change in energy in the system? It was through the enthalpy change, so delta H, that's the change in heat energy, the enthalpy change. So delta H, the enthalpy change for an endothermic reaction, is positive. Okay, so delta H for endothermic reactions is always positive. Delta H is positive. Okay, now again let's have a look at the energy level diagram for this. So here we have it, energy and progress of the reaction. Here my reactants have this much energy and my products now have more energy than my reactants. Okay, this time it's really important to understand where the activation energy distance is from the reactants all the way to the top of the curve. Okay, so for an endothermic reaction, the activation energy goes from the reactant line all the way to the top of the hump, effectively. Okay, so activation energy is the minimum amount of energy required to make a reaction happen. So remember, in an endothermic reaction, energy is absorbed into the reaction. Therefore, if a thermometer was nearby, its recorded temperature would fall. Examples of endothermic reactions would include thermal decomposition reactions or sports injury compact instant ice packs. Okay, so just a reminder then of what thermal decomposition reactions are. Basically, a thermal decomposition reaction is where you use heat to break up a compound. So thermal decomposition reactions, this is using heat to break up a compound. So I've got to put in heat energy to make that calcium carbonate break up. So put in heat energy to the calcium carbonate to make it break up into calcium oxide and carbon dioxide. So heat has to be put in to get the calcium carbonate to break down. Therefore, delta H is positive for thermal decomposition reactions. Delta H is positive. Okay. So now, if we just have a little think about how this comes up in exams, generally you might have to draw an energy level diagram or an energy graph. Okay. But also they do like to give you a thermometer and show a temperature reading on a thermometer, and all you've got to remember is that when the temperature reading on the thermometer goes up, the reaction is exothermic. That's usually the question. So when the temperature on a thermometer goes up, the reaction is exothermic. Okay? When the temperature on the thermometer goes down, the reaction is endothermic. So let's just remember that. When the temperature on the thermometer goes up, the reaction is exothermic. And when the temperature on the thermometer goes down, the reaction is endothermic. Okay, that's it for today. Thank you for watching. Don't forget to like and subscribe and click on the bell notification to stay updated.